Good morning. I want to take a minute to talk about problem solving with formulas. So I already did a part one yesterday where I discussed just basic direct translation. So what we want to do is we want to apply that idea of direct translation, create formulas, and then learn how to use them. Now, when you're dealing with formulas, a couple of things can happen. One, you can have a geometric formula. So you can have problem solving where they're talking about like trapezoids or area, perimeter, circumference, stuff like that. So you just have to go and dig up that geometric formula from that formula sheet that's in Moodle. The second thing they can do is you can be given a formula for something generic, population growth in a particular town. Okay. So they'll, in a situation like that, the problem would tell you what the different variables mean, and then you would use those variables, fill in particular information that's given to you, answer the question. The third thing you can do is you can be given a word problem where you're not given a formula, but you're given enough information to create a formula. And then you can use that formula for a particular situation. So a lot of problems like this would be like a company that caters charges a flat fee of $250. And then in addition to that flat fee, $25 per person, okay? Something like that. So you then assign the variables to the unknowns, you create the formula, and then I could ask you a question. Okay, if somebody's gonna have 75 people to an event, how much would this catering company charge them, okay? So I wanna take a minute and kind of look at all three of these, okay? So the first type of example is where you're given a geometric formula, okay? You would have done a lot of stuff like this back in unit one, not unit one, I keep saying unit one, I mean tier one. So back in tier one, when you were in the geometry unit, you would have done stuff like this before. So you could have something like this. You plan on building a circular patio. If you want to have a diameter of 15 feet, what would the area of the patio be? Okay, so in this particular question, we're not given a formula explicitly, like they don't have the formula sitting in the problem, but they give you enough information that you know you're looking for the area of a circle, okay? So I'm gonna sneeze. That's what I love about these videos. You never know what's gonna happen. Okay, so you have a circular patio, we're interested in the area, and we have a diameter of 15 feet. Okay, so we have plenty of information here to find the area of this patio. What we don't have right in front of us is the formula for the area of a circle. You would want to go into Moodle, pull up the formula chart that is in your Moodle shell, and find the area for a circle if you don't already know it. So area for a circle, pi r squared. Now, in this particular problem also, since this is a real world, like live problem, we don't want to leave pi in our answer. We don't want that exact answer where we figure out the radius, we square it, and then we just say whatever pi, okay? We want to go ahead and estimate this. So let's say pi in this case is approximately 3.14. That's what we'll use for this particular problem. So keep in mind, diameter is 15 feet. We've got a circular patio and we want the area. Now, again, let me write it here just so it's in front of us. The formula for the area of a circle is pi r squared. We know that the diameter is 15 feet. Now, if you go back to your work in unit one, I said it again, tier one, if you go back to your geometry work in tier one, hopefully you'll remember that the radius is the diameter divided by 2. So in this case, 15 divided by 2 is 7.5 feet, okay? We're gonna be using a radius of 7.5, okay? And then don't forget, we're gonna use pi is approximately 3.14. So area is approximately 3.14 times 7.5 squared. Now, for something like this, if I was in a classroom and I had you all doing worksheets and stuff on paper, I would absolutely expect to see your work. You can use your calculator for some stuff, but you need to show me your steps, okay? So 7.5 squared is 56.25. And then we need to go ahead and multiply the radius squared, 56.25 times 3.14, which is our approximation for pi. So the area of this particular circular deck is 176.25 square feet. So you could absolutely see problems like this where a formula, a geometric formula, is involved, okay? Another type of question is where you're going to be given the formula, okay? But it's going to be kind of an arbitrary formula for a very, very specific situation. And then you're going to take information from the problem, you're going to fill in the formula, and then answer the question. So a town is expected to experience a 6% growth this year. Whoops. The formula n equals p plus 0.06p, where n is the population after growth. I guess I should put forgot a word there. Use the formula n equals p plus 0.06p, where n is the population after growth and p is the current population. To determine the expected population after this year. Now, unfortunately, I'm using my tablet and I don't really have a good way to pull up problems that are typed up. So it takes a little bit of time to write them. It's clearly messy. We'll get through. So a town is expected to experience a 6% growth this year. Use the formula n equals p plus 0.06 times p, where n is the population after growth and p is the current population, to determine the expected population after this year, okay? 0.06 is the same as 6%, plus indicates growth. N, think of that as like your new population. And then this P right here, we're starting with our initial population, what the current population is right now. And to that, we're going to add 6% of that same population. Okay, so this is a situation where you've been given a formula, but it's for a very, very specific situation. Okay, so that was a little redundant sounding, but you've been given a formula that fits one very particular situation. This formula right here can't be used for anything other than a town expecting a 6% growth. Okay, so let's go and figure this problem out. Okay, we need one more bit of information. We have n equals p plus 0.06p. We can use this formula to figure out the population of any town that is experiencing a 6% growth. But what we need is either n or p. So in this case, we want to figure out what p is. So let's say current population is 7,500 people. Okay, you have to be given some information. Okay, so you've got the formula and then you have to be given information for one of the two variables. Okay, so in this particular case, we're going to say that we have the current population. So we want to find the new population. We take the current population and we add 6%, whoops, of the current population. All right, so this right here represents the growth. This right here is the current population. You add them, you get the new population. Let's see, 7,500 times 0.06 is 450. So we get 7,500 plus 450. In this particular situation, the 450 represents the people that you're expecting to join your town, either by birth or people moving. So we would say N equals 79.50. So this is kind of on two screens. Let me go back a screen. So we started out with a town is expected to experience a 6% growth this year. Use the formula N equals P plus 0.06P, where N is population after growth and P is the current population to determine the expected population after this year. And then I ran out of room. On the second screen, we have that formula again, so we don't forget. And then let's say that the current population is 7,500 people. We take 7,500 people, we plug it in for P, and we do the order of operations. So we multiply and then we add, and we get that after a 6% growth, this town should be at 79.50. All right. So you've seen two examples, one where they just recall a geometric formula, another where you're given a very arbitrary formula for a very specific situation. And then the third is going to be very similar to the last example, but in this case, you're not given the formula. It is up to you to use your direct translation skills to create the formula and then use the formula to answer the question. So Bob is a home improvement specialist. This is another thing. You need to get used to a lot of extra information in your problems. Bob is a home improvement specialist. Okay, great. It's kind of useless information at this point. For basic home repairs, Bob charges $95 and then an additional $20 per hour, of work. Okay, so what we're going to do first before we get into the particulars is let's go ahead and create the formula, and then we'll get the rest of the problem on the next screen. So in this particular situation, we have a couple of things that are missing. The total charges, okay, we don't know what the total final cost is going to be for this person who's getting home improvement work done. And then we've got this per hour of work. So let's let C equal total charges. So the total charges are that flat fee of $95 plus any additional hourly work. And then let's let H equal hours of work. So this is where we're using that direct translation. We're taking some time. We're using our direct translation skills to assign variables to the unknowns, the total charges and the hours of work. So what we would get here is the total charges equal, well, Bob is charging you $95 whether the job takes an hour or 10 hours. So he charges you $95. In addition to that, Bob is going to charge you an extra $20 for each hour. So to figure out the hourly rate, we're going to take 20 and we're going to multiply it by the number of hours. And then to finish up the total charges, we would add 95. So let's go to the next page. How much will you be charged if a project takes Bob 5.5 hours? All right, well, let's bring back that formula. C equals 95 plus 20H. We're trying to figure out how much we're going to be charged. So that tells me we do not know what C is. What we do know is that Bob is going to take 5.5 hours. So we go in, C equals 95 plus $20 for each hour of labor. All right. Bless my heart. All right, so we get C equals 95 plus 110. And then the final charge, let me see, I'll have to squeeze it over here, I'm out of room. C equals, well, 95 plus 110, you add those two up and you're going to get $205 total. So Bob is going to charge you $205 if a project takes him 5.5 hours. Now let's do another project. I got to do a little work before I write the problem. If Bob charges a total of $240, how many hours did Bob work on the project? Okay, well, in this case, we know the total charges. So if we bring back that formula, we know what C is. C is 240. What we don't know is how many hours it took for Bob to do this. So we don't know what H is. So let's go ahead and fill in C is 240. I had to write this up a little higher because I'm going to need a little bit of room here because we're going to have to use some algebra to solve. So hopefully at this point you've already worked through how to solve single step or multi-step equations. What we need to do is isolate the term that contains the variable. So in order to isolate the 20h, I need to move the 95. I would move the 95 by subtracting. So let's see, we get 145 equals 20 times h. At this point, I need to undo the multiplication of 20 and its variable h. The way we undo multiplication is division. So I divide, 20's on the right cancel, that leaves me with just an h. And then 145 divided by 20 is 7.25. So if you were charged if you were charged 240 hours, crap, I like really messed this one up. Let me start over. If you were charged a total of $240, that would indicate that Bob had worked 7.25 hours. Okay. Now, in this particular video, we went over just 3 basic things that can show up with formulas. One, where you have to go and recall a geometric formula. If you don't have them memorized, it's not a big deal. Just go back to your formula chart that's in Moodle. All right. We did another one where a formula was given to us, a very arbitrary, like very specific formula for a very specific situation. Okay. So that was the one where we did the population. And then the third situation is where you're given enough information to use direct translation to create a formula and then use that formula to answer questions. Okay. So formulas aren't too bad. Some of the geometric ones can get a little nasty if you have a really especially tough geometric type formula problem. Just send me an email and we can go over it specifically because there are tons of things they can do. There's one question that comes up all the time where you have 2 pizzas. You have like a large pizza and a small pizza, and you have prices associated with these pizzas, and you have to figure out which one's a better deal. Those can be kind of tough, but in general, it's just basically what you did back in the geometry unit back in tier 1. It's just you're doing it now, like in the algebraic section, the algebra section. The other 2, the one about population and the one about the hours that Bob works, those are pretty common. You'll see those a good bit. If anything weird shows up with formulas, just let me know, okay? I can make new videos. I can meet with you specifically on Zoom. If you do come to Zoom prepared. You can't just come to Zoom and be like, I'm really confused. Okay, confused about what? I'm confused about Unit 9. Okay, Unit 9 has bunches of topics. Which topic? Well, I'm confused about formulas. Okay, that's great. That's a little more specific. We can help you there, but it's even better if you have a specific problem that you're like really stuck on. You can't just be like, yeah, there was this problem about like painting or something. That doesn't help me at all. Okay, I need you to have the problem ready. So if you join us on Zoom and you've got like really specific questions, please have that ready up so you can share your screen with us, or so you can read a problem out to us, or whatever the case may be. Okay, happy to help. You just got to reach out to us. Okay, let me know if you need anything.